Hey, math. All right. So today we're going to start actually getting into graphing and transforming and stuff like that with our sinusoidals. I kind of touched on it yesterday. What, well, what would affect these properties, right? And I said if you wanted to change the period length, that would be a horizontal stretch or shrink. Well, horizontal stretch and shrinks are always a multiplication on the inside, right? Remember Hilbas, horizontal inside opposite. So horizontal stretch or shrink is going to multiply a multiplier on the inside. There's the multiplier on the inside, letter B. I said that the amplitude can be changed by using a vertical stretch or shrink. Well, vertical, outside, same. Vertical stretch or shrink is a multiplier on the outside. That A. And I said that this midline, which is supposed to cut the graph in half, which is supposed to be on the x-axis, it can shift up and down. So shifting up and down is adding or subtracting on the outside. That's going to get us this. I know there's a letter there that I haven't mentioned yet. That's okay. We'll talk about it in just a second. So this letter A, this affects our amplitude. The letter B affects our period length. And by the way, this is true for both sine and cosine. You notice they have the same general function. One just says sine, the other says cosine. And this last one affects the midline. So what does this affect? Well, hopefully we all know that adding and subtracting on the inside is shifting left and right. In trigonometry, shifting the wave left and right is known as a phase shift. So what does it affect? Well, it is the phase shift, but notice, or remember yesterday I said, and I put it in quotations and you guys made fun of me for putting air quotes with my fingers in the camera, the beginning point, where I said that the wave begins, quote unquote, at the midline for a sine, and that the cosine wave begins at a maximum, that's going to affect your beginning point. Basically, it's going to affect where you draw your first waves start, known as a phase shift. So the amplitude is just a vertical stretch or shrink. The amplitude, though, is a distance. How far away can this graph go from its midline? How far up? How far down? Since it's a distance, it is always positive. That means that the amplitude is always going to be the absolute value of whatever number is on the front. Because having a negative sign on the front is the same transformation it's always been. It's just a reflection over the x-axis. So if you see a -3 in front of your sine function, it's been reflected, and the amplitude is now 3. Amplitude's always positive. Absolute value of A. The period length, what we saw yesterday, is supposed to be 2 pi, right? It's supposed to be 2 pi. So if you put a B term in here, you're multiplying by something, but remember, horizontal, inside, opposite. It looks like you're multiplying by B. No. You're dividing by B. So the period length is going to be 2 pi times 1 over B, or 2 pi over B. More specifically, the absolute value of B. Again, a negative sign in there is the same transformation it's always been. It's just a reflection of the y-axis. So if you see a negative sign on the front, disregard it when you're talking about amplitude. If you see a negative sign in front of your x, disregard it when you're talking about period length. Period length and amplitude are both absolute values. I'm going to be lazy. I'm going to be really honest here. When I write the formula, I'm going to write 2 pi over b. I'm not even going to bother with the absolute value signs every time I use it. Cool with that? Just know that I'll be ignoring a negative sign if I see it. The midline, also known as the principal axis, is supposed to be y equals 0. So if you shift it up or down by this value d, your midline then is y equals d. And you do need to be really careful about this because a lot of times IB questions will say write an equation for the midline. And if you don't write y equals, you're not going to get that mark. Just watch out for that. It's like saying the equation of the axis of symmetry, you have to write y equals or you don't get that mark. It's the same idea. All right. Yep. So our job here is to sketch one period, and then it wants us to state the transformations. I don't really want to state transformations. How about we just say them instead of write them out? You good with that? All right. Cool. I'm looking for a pin code. Oh, there we go. I was looking for black. Looking for my black pin. So what do I see here? Tell you what I'll do. I'll list out the information that I can see before I go to do the graphing, because when the equations get really complex with lots of transformations, that's how I always do it. I list out all the information that I have, and then I approach the graph. The first thing I always look for is my midline. That's just one of the things that I've learned to do. Figure out where that midline is, because I'm going to go ahead and put that right on the graph. Because there's no adding and subtracting out here, my midline is y equals 0. My amplitude is 1 because the number in front of the sine function is missing. So clearly it's 1. There is no number sitting in front of my x. That means my period length is exactly what it should have been, 2 pi. So all right, 2 pi over b is 2 pi over 1, which is 2 pi. And then lastly, where do we want to begin? So we know that this is a shift pi over 3 units to the right. That means this sine wave that is supposed to begin at its midline and then go up will not start at 0, 0. It has to shift to pi over 3 and then head up. Basically, it's the exact same verbiage that we use anytime we're talking about what makes the inside of the parentheses equal 0, things like that. It's literally what makes the inside equal 0. That's where you always want to begin. This is a positive sine wave, so what I like to do is I like to just draw what it should look like. It's going to look like that. Because if I put a negative sign in the front of it, I would have drawn that upside down. Cool with that idea? All right. Again, these questions, they're not that difficult, what we're working with right now. This is the process that I go through regardless of the difficulty of the question. I just get used to it. That's crooked. Our period length is 2 pi. However, we begin at a pi over 3. So if I begin at pi over 3, where do I end? Wouldn't it just be 2 pi after pi over 3? So you have to add 2 pi to that. Pi over 2 pi is 6 pi over 3. So I would be ending at 7 pi over 3. That's the full 2 pi. If you recall yesterday, I said that your sine and cosine waves can all be split into 4 pieces that represent the quadrants, like that. So what I'm going to do is I'm going to take the span, which is the whole period. I'll cut that in half. That's going to be at 4 pi over 3. And then I'll cut those in half as well. My midline is the x-axis. So I'll just do that. Makes it look like it was the x-axis. Amplitude is 1. That means it's going to go up to positive 1, down to negative 1. And I only drew that so tall because I wrote these numbers really tall. Sine wave begins at its midline and goes up. And we said that's going to happen at x equals pi over 3. So begin here, and then maximum, then midline, then minimum, then midline. There you go. One period of sine wave. The only transformation was shift right pi over 3 units. I'm going to run out of space if I keep writing this large, so I'm going to have to write a little bit less, or write maybe a little bit smaller. I don't know. Maybe I'll section it off. Section it off, and I'll write smaller too. Part B, there's only one transformation. That means this is going to be a cosine wave exactly the way we expect it to be. Its midlines at y equals 0, its amplitude is 1. It's going to begin at x equals 0 because that's what makes the quote-unquote inside equal 0, because 3 times 0 is 0. The only thing that's different for this one is we do have a horizontal stretch or shrink because there's a multiplier in front of my x. The period length is supposed to be 2 pi over b. So it's going to be 2 pi over 3. Our cosine wave is only going to cover 2 pi over 3 from left to right. And it begins at 0 because that's what makes the inside equal 0. Life is easy because I'm just going to do this. 2 pi over 3. I'm going to cut that space in half. Half of 2 pi over 3 is pi over 3. And then I'm going to cut the thirds in half to give me sixths. So that's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. There's my 4 quote-unquote quadrants. 1, 2, 3, 4. Amplitude of 1. So from 1 to -1. And cosine wave, a positive cosine wave, looks like this. Looks like a bowl, kind of, like a cup or something like that. It always begins at a maximum. Positive cosine wave always begins at a maximum. And remember what I told you yesterday? From max to max is a period length. What can I always find halfway between two maximums? Minimum. And guess what can always be found halfway between a minimum and a maximum? Well, a midline. For this one, it does happen to be 0. But if I shift it up or down, then it's always going to be a midline. There you go. What I'll do is I'll handle C over here, and I've got some space down here for D. So far, so good? It's not too crazy hard? Okay, good deal. All right, part C. Part C has 2 transformations. It's going to shift left, and it's going to shift up. Amplitude has not been changed. Period length has not been changed. Our midline then is y equals 1. And the number that makes the inside equal 0 is where we're going to quote unquote begin. We're going to begin at negative pi over 6. Period length is 2 pi. Oh, so if I begin at negative pi over 6, I'm going to have to end 2 pi away from that. Remember, 2 pi is 12 pi over 6. So if we end at negative 1 pi over 6, we're going to end at 11 pi over 6. So we have to add 2 pi, which is 12 pi over 6. And it is a positive cosine wave, which means it looks like this. Let's get it thrown on there. Need a little bit of a negative x-axis this time, because we do have to begin at a negative number. Picture how to run a scale because I don't care. There's our period length, 2 pi. Cut the space between the beginning and the end in half. And I don't know. What is that? 5 pi over 6? Yeah, that's 5 pi over 6. And then halfway between those, do your best, is where you're going to find your other ones. And what is that? That's 2 pi over 6, so pi over 3? Yeah, so that's pi over 3, and then 8 pi over 6, which is 4 pi over 3. Whatever. Our midline, though, yeah, our midline is that y equals 1. That makes this interesting because our amplitude is 1. That means our maximum y value is 2. I wrote y instead of 1. Whoops. What? Alrighty. Draw this shape, beginning at negative pi over 6, ending at positive 11 pi over 6. Halfway between your maximums is your minimum. Since your midline is at 1 and your amplitude is 1, your minimum value is 0 because it's up 1, down 1. And halfway between a minimum and a maximum is always going to be a midline hit. And then the last one, negative sine of x. Negative sine of x. Yeah, I'm out of space, so I'm going to go ahead and do it down here. The midline is unaffected, the period length is unaffected, the amplitude is unaffected. There is a single transformation. Reflect over the x-axis. So all we're going to have to do is realize that the graph now begins at the midline and goes down instead of going up like it should have. That's all we have to do. There's 2 pi. Here's pi. Pi over 2, 3 pi over 2. Positive 1, negative 1. Midline. Sine, and 0 makes the inside 0. So sine begins at its midline, and then usually heads up, but this one's got a minus sign, so heads down. Very easy. Actually pretty boring, to be real with you. Questions, comments, concerns before we flip it over and get to some more interesting questions? Yeah. So you know it's supposed to be 2 pi, right? The period length? This is a multiplier on the inside, horizontal inside opposite. So it's always the reciprocal. Remember, if we were doing f of 2x, that's actually a horizontal shrink, factor 1/2. This is f of 3x, so it's a horizontal shrink, factor 1/3. So it's literally 2 pi times 1/3. Yes. Yes, why? Yeah, it's a 2-day lesson. Why? Oh, no, it's a 2-day lesson. Not to mention, if you've seen the homework assignment. Oh. Okay, well, if you guys would shut up and let me finish the lesson, maybe we don't have anything to learn tomorrow and you do the homework in school. Go faster, she says. It's 2 days because I will have to make sure that you have a deep understanding of how the questions work in order to pull off IB style things. That's why. All right. It says sketch the graph of this. We're only going to go from 0 to 2 pi. Let's see what's up. First of all, my midline is at y equals -1. My amplitude is 3. My period length is supposed to be 2 pi, but this one has a 2 in front of the x, so the period length is 2 pi over that b value. Oh, our period length is just pi. So how many full cycles will get completed in the 2 pi that I have to graph over? 2 of them. I'll have 2 full waves here. Yeah. So if my midline's at -1 and my amplitude is 3, that means my minimum is a -4 because it's -1 minus 3, and my maximum is a 2, -1 plus 3. At least there wasn't a phase shift. That makes life a little bit good. My period length is pi, we said. So I'm going to put pi out there. Cut that in half. Pi over 2. Cut those in half to get your pi over 4s. My job was to go to 2 pi though. There you go. And said it's going to go down. It's going to go up to +2, down to -4. Midline was at -1. There. Awesome. This is a positive cosine wave, so it should have this shape. Should begin at a maximum and head on down. And since 0 makes the inside equal 0, our maximum will be at 0, 2. At the end of the period, I'd better be at its maximum again. Halfway between a pair of maximums is a minimum. Halfway between a minimum and maximum is always a midline hit. And then you just wash, rinse, repeat for the second pi. When's your pinning ceremony? Tomorrow night. Oh, okay, so you can get started tonight and finish it tomorrow. No, we start tonight and finish it tomorrow in class. Well, I mean, it's up to you. It is a huge assignment, though. It's really, really large. I'm sorry? I don't know. Congratulations, you done it. Can I go to the next question? No, thank you. I do not want to sniff your peanut butter. What a weird thing to have in my video. Okay. Now this is a good question. Psst. This is a good question. Very little information is given to you. What you know is that you're going to have a positive midline, and you're going to have an amplitude that's not 1 because it has to dip below the x-axis. We're not allowed to assume what the midline is. So what do you think you could possibly do here? It's almost like you were given 2 points of information and there's 2 variables that you don't know. What does that usually mean? And then what? You have 2 unknown variables though. There it is. It's a system of equations. There's a reason why you were given 2 pieces of information and there are 2 variables that you're solving for. System of equations. Your x values are going to get plugged in, which means we will need to evaluate sine of pi over 2 and sine of 7 pi over 6. And since I already know that, I'm going to go ahead and draw those real quick. Sine of pi over 2 on the unit circle, this is pi over 2. The coordinate at that point is 0, 1, and r equals 1. Sine is y over r. And the other one is going to happen at 7 pi over 6. Well, that's a little bit more than 1, isn't it? That's in quadrant 3, 7 pi over 6. Picture not scale, never is. But if it's an over 6, what's the size of the reference angle in this triangle? 30. Yep. Across from a 30-degree angle, you can always find a 1 in a 30, 60, 90, but because I'm in quadrant 3, it's a -1. Next to a 30-degree angle is always a root 3 in a 30, 60, 90, but because I'm in quadrant 3, it's negative root 3. And the hypotenuse must be 2. There we go. Ready to rock and roll. Using 8 as your f of x, you're going to have 8 equals a times the sine of pi over 2 plus d. Well, let's see what sine of pi over 2 is. Sine is y over r. Oh, that's just 1. So that gives me that 8 equals a plus d, because sine of pi over 2 is just 1. Well, that's going to make life really easy because it'll be great for substitutions. Let's do the other one then. Using 0.5, I'm going to say 1/2. Using 1/2 as our y value, we get a times the sine of 7 pi over 6. So we come over here and we say sine is opposite over hypotenuse, or y over r. Oh, it's negative 1/2. There you go. You have your system of equations. We just need to solve for a and d. I would just go with substitutions. Solve for d here. And that's what I would do. Or, you guys like elimination? I don't want to do substitution. I'm going to use elimination. I want to distribute a 2 across this equation. There, much easier. I distributed a 2 across this equation so I didn't have fractions. Because now I can stack these two things. And I can add straight down. Adding straight down gives me that 9 equals 3d. Bless you. Therefore, we know that d is 3. And if d is 3, what is a? 5. Because a plus d had to equal 8. It's a simple question if you realize you didn't have enough information in the picture to figure out what the midline was and things like that. Using your x comma y's was your only option. Okay? So if you have two unknowns, you should immediately be thinking it's probably a system of equations, especially if you're given two pieces of information. And that brings us to the last example. Wait until people are, we ready? Just find the equation. I want the answer both in sine and cosine. Actually, there's an infinite number of correct answers. An infinite number of answers in sine, an infinite number of answers in cosine, because the waves, where they begin, completely, don't make that face, air quotes on the video. Where they begin is completely up to you. It's arbitrary. You choose. This picture does show you the midline. And this picture does show you the period length. Begins there, and then starts to repeat itself there. Or I could have said it began there and ended there. It doesn't matter. It's just how long until this pattern repeated itself. Our amplitude, remember, is going to be the distance from midline to maximum or midline to minimum. So the amplitude is just 1. Let's fill out what we know. We know our amplitude is 1. We know our period length is pi. We know our midline is y equals 1. That's good enough to get started. The period length is supposed to be 2 pi over b, right? So 2 pi over b gave me that period length of pi. When you have to solve for this unknown b, right now it's pretty easy to see what the number is. But when it's not so easy to see, all you have to do is switch these two objects. What you'll get is b equals 2 pi over pi. So these two guys right here, these bad boys will switch places, gives you b equals 2 pi over pi, which is 2. All right, ready for our equation. Student blue. Let's do positive sine first. Y equals positive amplitude sine of your b value that goes in front of x, and then because the positive sine wave is supposed to begin at x equals 0, and I can say this one does, then I can say there is no phase shift. And then just go plus 1 because the midline is up 1. Did I have to start it there? No. I could have been super duper extra if I wanted to, and I could have said it started there and made it a negative sine wave. So might as well, it makes for a good video. Let's say I'm starting here now. Now it's negative sine of, there is still a 2 in front, but if I'm saying I'm starting there, I have a pi over 2 phase shift to the right. That's just for you to realize that I could phase shift this as many times as I want to and still call it a sine wave, both positive or negative. Just depends on where I decided to start it. Holly wasn't looking that time, so she didn't have to give me the stupid face when I air quoted on the camera. How about cosine? Cosine is supposed to begin at a maximum, correct? So at what x value do I see that occurring first? At pi over 4. Amplitude is still going to be positive 1, or it's still going to be 1, and it's clearly a positive sine wave because we said we're going to begin here. I guess cosine of 2. But there's a phase shift. This one begins at pi over 4. So x minus pi over 4 plus 1. If you wanted to be super duper extra, you could have written it as a negative cosine wave and began it at 3 pi over 4. Just trying to get you to see the infinite ways that we could do this. And of course, I could shift it to the left if I wanted to as well. But that is it. Holly, you look like you have a question. Because if it begins, yeah, because it goes down instead of going up, that's why that one's negative. Yeah. Yeah, seeing cosine positive and negative is much easier. And because of that, a lot of our real world questions will be done using cosine because most things start at the bottoms of like Ferris wheels and stuff like that. Yes, ma'am? The 2 is on the outside of the parentheses because when you're doing transformations, remember it's horizontal, inside, opposite. The transformations are supposed to be read in the opposite order if they're distributed. But if you keep it factored, you can see what the shift was and you can see what's affecting the period at the exact same time. So you're going to want to keep the insides of that stuff factored. And if you ever see it not factored, pull a GCF and factor it. Okay? That'll make your life much easier. Great questions.